All right, ready? All right, so you want to take a look at linear regression, right? And correlation. We need to understand what those things mean, right? Everybody hearing okay? Right, your lemon over the handwriting looking blurry, right? It should be paper now. What's ahead of linear correlation and linear regression? Head up correlation and linear regression. Okay, good. So here's what we're looking at. We basically trying to find relationships between values. All right, so let's say I gave you some values, right? These are your X values and these are your Y values. For those who remember the little maps, right? If I give you Y is equal to 2X minus 1, what we'll normally do is substitute X values and obtain Y values, right? The values is substituting, those are your independent values. And the values you're obtaining, those are your dependent values. So basically, your X are all the independent values. And your Y's are dependent values. Right? So for example, if you want to take a look at how your marks will look based on the number of hours of study, right? You could use this equation. The equation that we ending up with that I'm going to show you now, that equation is called a linear regression. So we're going to get two variables, one that's dependent on the next, and we're going to take a look at how they're related and going to get an equation that could be used to estimate it. So for example, I could kind of figure out after a few sets of data, I can kind of figure out if you study for 10 hours, what your mark will be in applied math or something, right? So that's kind of the use of linear regression. So let's take a look at some of the things that lead up to this, right? So the first thing we can look at is we get some data, right? And when we get the data, when you plot the data, it's looking at something like this. Right? When your data looks something like that, that is called, anybody remember it from normal maps? What type of relationship is that? If your data looks like that. Anybody remember the maps there? Nobody remember any maps? What type of relationship is that? Anybody? Oh, very good. Very good. Very good. Nobody? All right. All right. That is called a linear, or that is called a directly proportional relationship. If I were to draw a line there, right? This is like a directly proportional relationship. That line, of course, is a regression line. We're kind of building up to that, right? So this relationship here is called a positive or a direct relationship. Right? Obviously, you can see as X increasing, Y increasing, or as X decreasing, Y is decreasing, right? So this here could get a correlation value, right? This here will have a correlation value, and the correlation gives us an idea of what type of relationship it is. If it's a positive relationship or a negative relationship, right? Or no relationship at all. The correlation value will give us that idea. So here we have a positive correlation, right? So it gives you an idea of what this word represents. Correlation basically, correlation carries a value. Sorry. Correlation carries a symbol, and the symbol is R. And all the R values lie between -1 and, lie between -1 and +1. This here is a negative correlation perfectly. Then you have a positive correlation, right? Everything lines up along that line. So you have all these different types of correlation, right? So correlation basically gives you an idea of how two values are related. Okay. Anybody writing? Copy it down. I want to turn the page. Anybody writing, sir? Anybody writing there? Right. When you have the x's alone, that is called a scatter diagram, right? So you may have guessed that a negative correlation might look like this. Right? And no correlation means the values all over and we can't really figure anything out. So you might get something like this. The values all over the place. We can't really tell if it's a positive correlation or a negative correlation. Right. While we're in correlation, let's see if we can work out that value now. So as I said, that value is between -1 and 1. -1 is a negative correlation. +1 is a positive correlation, right? And of course, 0 means no correlation. Everybody okay with that? So how do we find this value R? There are two formulas, right? There's one I'll give you now, and there's also one in the formula sheet that I gave you all. Right? So you can look back at that, right? So to determine R, we could use this. R is equal to SXY all over SX by SY. Right? It's kind of based on how the information looks, but the one that comes in the formula sheet, you don't have to learn that, right? So if you get used to using that, that'll be good. But sometimes you will see SXY is equal to this, SX is equal to this, right? So it's important that you know how to get those values, right? All right, so let us I'm gonna tell you what is SXY. Right, so these are some of the formulas that we need to be able to use. Right, so you can kind of use any version based kind of based on which one is easier to remember. I find the second one kind of easier to remember. All right, so I'm going to show you now how to use the formula. So basically, you're going to get X values, you're going to get Y values, right? You can easily find the mean, right? And then you need to get X by Y values and then sum it up. So you will get these values here, right? And then you have to get X squared values and Y squared values. And once you sum up these columns, you just plug in your values into this formula. And you're good to go. Right? I'm going to show you how to handle that now. That formula allows us to get the correlation value. All right, so copy it down or screenshot quick. All right, anybody writing? Nobody writing, right? All right, so let's go. I'm only going to give you a few values and you'll have to help me do the calculations, right? So X, Y, I'll give you a few values, 18, 42, let's change it to 40, right? 20, 62, let's just use 4 values, right? 60, 81, one more. Let's try to use 95, 109, right? So good. What are the columns we need? We need x squared, we need y squared, and of course we need xy, right? We have to find all of the bottom here will be the sum, right? Right, so we need the sum of everything, the sum of x, the sum of y, the sum of x squared, sum of y squared. Right, I need some help. What is sum of x? I have no calculator, so please help. What is sum of x here? 193. Anybody else have 193 for the sum of x? Nice. What is sum of y? 292. Nice. All right, help me work out x squared, please. X squared is how much? Right. Well, of course, you just square everything to get x squared. 18 squared, 20 squared, that are kind of small. Square 18, come on. Right, 18 squared is 324. Right? What's 20 squared? That's 400. 60 squared is what? 3600. What's 95 squared? $9025. Right? What you all got for the sum now? $13,349. Nice. Y squared. Do out y squared. 40 squared. 1600. 62 squared. 81 squared. 81 squared. And 109 squared. 109 squared, 21,000. Oh, 11881. And the total is what? 23886. Right? XY now. What's XY? 720. Next one is what? 20 by 62. 60 by 81. And the last one, 95 by 109. Right? And then add it up for me. Okay, good. So now let's try to apply the rules. Let's see if we could find the mean of x first. The mean of x will be 193. Oh, let me write the formula in case you all forgot. It will be the sum of x all over n. So that's 193 all over 4. Then you work out y bar, sum of y over n. That's 292 over 4. What is 193 and 4? Three significant figures. What's 193, right? 48.3. What's the next one? 192 over 4. What's the next one? 292 over 4 meant. 73 exact. Okay. So we have X bar and Y bar. So now we could go to our formulas, right? Let's see if we could find first thing S, X, Y. So using the small n formulas, smallest formulas, 1 on n is the sum of xy minus the mean of x by the mean of y. So that's 1 on n by, sorry, n is 4, right? 1 on 4 by 17,175 minus 48.3 by 73. How much you got there for SXY? Take your time, huh? What you got for SXY? No rush, but before the class finish, would be nice. Seven 767.85. 767.85. In the end, our answer has to be between -1 and 1. So be careful, right? We had to be accurate in all these things. That's okay. 767.85. Next one, SX, right? SX. So is the square root of the sum of x squared, which we have already, over n, right? Minus the mean, and then you're squaring it. So it's the square root of 13349 all over 4 minus the mean of x, which is 48.3 squared. Come on, where's that for SX? And in a similar way, we find SY. All right, tell me what you get for SX. Everybody agree with SXY, right? 167.85. Sorry, 767.85. Yeah, okay. Right, Jude got 31.7 for the next one. Okay, good. And then work out y squared from her. Right, 25.3. Okay. Right, now come to the formula, SXY, SXY. So you're trying to find R and R, right? SXY 767.85 divided by 31.7 by 25.3. Oh, well, somebody who's in the calculator now. Anybody else not getting SXY? Saskia again, something different for SXY. So according to this, we got 0.957, which kind of makes sense if you look at the values. as X increasing, Y increasing clearly. So it appears to be a very high correlation. Right? It appears to be a very high correlation. Right? There's a way to put the holes in the calculator, but or you could Google that for homework, right? I really can't remember. Yeah. Anybody else got a different value for SXY? How much again, Saskia? Remember, you just put in this right here. And a little minus sign in the middle. That shouldn't be too hard. 17,175 divided by 4 minus 483. Use it brackets, right? Use the brackets that I have there in red. Saskia, you get it now? That's not. I just waiting on Saskia to check it back, right? All right. When you get to correlation values, there are different things you get now. Okay, nice. Nice. When you get to correlation values, right? We need to learn to be able to like make a little summary. What does 0.9 mean? Right? Is it high? Is it low? What type of correlation is that, right? So I'm gonna give you a little chart here that'll help you to figure that out, right? People use different words, but it's the same meaning, right? No, not just positive. You need to be able to say strong or weak or moderate or so on, right? So let's create a little chart, right? These are 4 correlation values. So let's say your value is between 1 and 0.9. Then let's go between 0.7 and 0.9. Oh, you want to screenshot it? All right, hold on. Yeah, okay. I'm going back now, right? There's a real important chart, right? So that's 0.9 to 1, 0.7 to 0.9. 0.5 to 0.7. All right, so the first one is very highly correlated. Between 0.7 to 0.9, we could just leave out the very and put highly correlated. Between 0.5 to 0.7, right, we could say moderately correlated. Now let's go 0.3 to 0.5. So let's use low correlation. right? Anything less than 0.3 is little slash, right? Little to no correlation, right? Same thing applies for negative, right? Same applies to negative values, right? So those are the general kind of breakdown, those are the words that I could use. Okay, so that's little to no correlation. Right, so you should kind of see the values open out. All right, so this table important, right? Very, in case you're not writing, make sure you have this on, right? Because after every question, they like to ask you what type of correlation is that? Bim, 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 bim. Anybody writing still? Everybody done, right? Okay, so I'm gonna give you one, and you just tell me what type of correlation it is. All right, so what type of correlation is this? Right, you could work it out to the little table, right? So we have 27, 43, 62, 89, 72. Right? 27, 43, 62, 89, 72, 48, 50, 81, 75, 60. Right, do a little magic there, find R and tell me and describe the R value for me. What type of relationship it is. So Judy wasn't working out all the time. Now you want to go back and watch his slides? Yeah, fellas, bye. Oh, shucks, Jude. I'll leave your thing right here. That means nobody else doing it. Oh, Ada wanted it. All right, all right. Right, just to make sure that we have the same statistics, I'll just ask you what these values are, right? Trying to get your values messages. Right? What you'll get for sum of X and sum of Y and right? 19527. Then I'm seeing, oh wait, that's the wrong one. 19527. Sum of y squared is 20,560. And what is xy? 19463. Right, and then find R from now, please. Find R and make a comment. When you get your R value, make it comment about it, right? Yeah, message value. It won't be highly, yeah, it'll just be, yeah, highly. Highly. What answer y'all got there? .0 point. Okay. Anybody else got that? Right? Where how much you got? How much you got? Yeah, then we work it. Okay. Just give me a little help. What you got for sum of xy and sum of x and sum of y? What you got for those values? Where are you still doing this, boy? Sum of xy, one person has 212.52. Sum of x, 21.7, and sum of y, S of y is 13.2. Check it back, see if those values close or off. Saskia, again, these values. Got them, okay. How much you got for your R? Okay, good. Ver, what you got for your R? Varun? Saskia yet? Kalakin, okay. Right, so yes, so you can say highly correlated, and you have to state the sign, right? So it's highly positive correlated. Right, anybody having issues with this? They could see it could be a little tedious, but you will recognize when you're doing past papers that sometimes they don't ask you to work out sum of X and sum of Y and sum of XY, right? They actually give you those sums, so just to remember the formula, right? So what you have in front of you there is one version of the formula. I just want to show you one other version, right? Oh, wait, well, what you got for SX, Y, and SX? That was just one person values. What you got? 1062.6. What's the next one? $48.6 and 29.6. Anybody else got those? I didn't work it out, sorry. I didn't work it out. I was just looking at somebody else's. Which values you all got? The first set or the second set? Rajiv said he got the first set of values. Jude, check it back now. Yeah, most people getting the first set. All right, so let's check it back and make sure that. All right, but check it back again. Coincidence, probably. All right. I also want to show you the next version of the formula. The reason for that is that in exams, this one right there, right? So you do have to stress about you don't have to stress about trying to remember it something, right? So what you said. So the next version of the formula looks like this. I'm taking this off, right? All right. So the next version of the formula is this one here. Instead of calling it just correlation, the correct name is product moment correlation coefficients, right? Or in short, the correlation value, right? So this here is the next version of the formula. The good thing about this version is that Right. The good thing about this version is that you don't need to find SX, Y, and all those things. All you have to do here is know what N is, right? Just find sum of XY, sum of X, sum of Y, and then plug in everything in here. It's a little harder to remember, but basically they're giving you this, right? So it's just to be able to use it. So I want you to do me a favor. Take your SXY values, the SX values, and your sum of, sorry, take your sum of XY values, your sum of X and sum of Y, sum of X squared and sum of Y squared, and put them into this formula, right? And tell me what you get for your R value. Same example as before, right? Same example as before. So write this formula down, N over the sum of X, Y, and so on. And then plug in the values, straight in the calculator, and tell me what you get. Finish. Just tell me what you get, please. Even with your values, Jude? Oh, okay, okay, right. How much you get, how much you get, Rajiv? Almost, okay. All right, so basically this might be the one you might remember in exams, right? Right here. Very doing anything there? Related to applied? There? Oh, okay. All right, so yeah, so you're supposed to get back close to the same value, or probably the same value, 0.74. All right, we take a little while, but the important thing is that we know how to find correlation and we know how to get SX, Y, and those values, right? The next thing we're moving on to, I'm not going to do it today because it will take a little while. We're going to use this here now. Remember, I told you all about the equation of the line called the regression line. We are going to learn to find the regression line of Y on X, right? So you're basically going to get Y as MX plus C. We need to get M and we need to get C, right? M is what you call it coefficients, which is B, and then we're going to get C using this formula here. All right. So I'm not going to force you into that today. But what I want you to do for next day, you need graph paper because we had to practice just one scatter plot. Right? We'll do a scatter plot and I'll show you how to go from this scatter plot to put in the regression line. All right, but again, here are all the formula that you will need for this, right? You need to find sum of X, sum of Y. You need to find B, that's called the regression coefficients, and then you need to get A. So once you get B and A using this formula and this formula, that's it. You'll get your regression line, right? And the 0.74 is a kind of hint of what your value should look like, right? You should get a positive gradient, right? So it means that your B value should be positive. Okay, so just a little guideline of what you should end up with. Okay, all right. So for today, we wrap up there. Next day, we move on to the actual regression line. We do a few of those and wrap up that part of it. Okay, so that's it. You can log out. I shall see you all next week, please. All right. All right, bye.